Now, this was a informal introduction into modeling with Petri nets. Next, I'd like to become a little more formal by formally defining what we mean when we talk about a Petri net. The first type of Petri nets that I would like to introduce are so-called condition event nets. Condition event nets can be introduced by first defining a so-called net. A net is a triple comprising C, that is the set of conditions, E, that is the set of events, and F, that is the flow relation. So for these three elements of the tuple, we require C and E to be disjoint sets. Well, that's what we have. That's how we have used them so far. And furthermore, the component F of this tuple is the so-called flow relation. The flow relation is a subset of C times E, and in combination with and then taken the union with a subset of E times C. So that means very clearly that we are only connecting by using the flow relation conditions to events and events to conditions, but we are not connecting conditions or events among themselves. Now, next, I'd like to introduce a term that we have already implicitly used during our examples. I'd like to introduce the terms preset and postset. Let n be a net and let x denote either a condition or an event. In most of the cases, x will denote a condition, but the definition is phrased in such a way that x could also denote a condition. So usually x is an event. So now we introduce the notation dot x, where dot x is the set of all elements y, such that y is in this relation to x, and dot x is called the preset of x. So what is actually the preset of x? Let's look at our example. In our example, let's assume that x denotes this event. Like I said, in most of the cases, x will be some event. Then the so-called preset consists of these two conditions. Now, in case the preset actually denotes conditions, that means in case x actually is an event, we will also call the set of preconditions. So these two conditions are the so-called preconditions. Now, furthermore, in a similar way, we introduce the notation x dot. X dot means all those elements for which x is in that relation to y, and all those elements y are called the so-called post set of x. Let's again look at our example. Let's assume that in our example we are using this event as the element x. Then the post set consists of just this condition. If actually the post set is a set of conditions, we will call this post set also the post conditions. So this is what we have used in a number of cases already when I explained these examples. Now for the Petri nets that we would like to model, we are usually trying to exclude some types of nets that would just make our life more complicated. We would like to exclude some type of nets that would make the analysis more difficult. Therefore, we look at, for example, so-called loops. What is a loop? Well, let's assume that we have a condition and an event. We have a loop if the condition is in the flow relation with the event and the event is in the flow relation with the condition. So this is what we have, for example, in this simple example over here, in which this could be our condition and this could be our event. And we see that we have edges connecting the two in both directions, which means that we have such a loop. Now, loops are in many cases not very useful, because what will happen if we have such a loop in a condition event net? Well, let's assume that initially there is no token on that condition. If initially there is no token on that condition, then this event can never take place, and it doesn't make sense to include this part of our graph into the overall net. And if we assume that this condition is initially met, then later on it will always be met, so it doesn't provide us any insight into the model, and therefore we could leave out that particular condition right away. So therefore, in many situations, we are requiring nets to be pure. Not in all situations, but in many situations, we are requiring nets to be pure. A net is pure if the flow relation does not contain any loops. So that's something that we try to avoid in many cases. There's another situation that we try to avoid. A net is said to be simple if a certain situation is not possible for that net. This situation is a situation in which two elements have the same pre and post sets. I'd like to include an example there. On the left, we see an example where we have for N1 and N2 exactly the same pre and post sets. Now, including such a situation in a net does not make too much sense, because whenever these preconditions are met, one of the two events can take place. We have to consider both possibilities. This complicates our consideration, and there is no way that we can actually prefer one event over the other, and it would be best just to replace these two events by a single event, and then keep in mind that in practice, in our real world, that single event might reflect two events in our real life. It's similar in the right part of our slide over here. Let's assume that these two nodes are the two nodes that we are considering. Again, we have the same pre and post set, and again we have a situation where this part of the net is just making our life more complicated. In practice, it will be very difficult to distinguish between the two kinds of conditions, and it makes a lot of sense just to merge the two conditions and just to consider these two conditions as being one. So these are situations that we would like to avoid in our nets. Now this leads us to the definition of the first type of Petri nets that I would like to consider in this lecture. This leads us to the definition of the so-called condition event nets. Condition event nets are simple nets with no isolated elements meeting some additional restrictions, and well, that's really the definition of condition event nets. So that means we are requiring that these nets are indeed simple. For the time being, we are not requiring that these nets are pure, but in certain situations we need these nets to be pure. Also, we require that there will be no isolated elements. That makes a lot of sense, because if we had parts of the nets that contain isolated elements, we should consider these isolated elements separately and not consider the net as a whole. So that means that now we should more or less know what we mean when we talk about condition event nets. There may be the question, well, what are actually these additional restrictions that I haven't really formally introduced? Well, these additional restrictions require all events to sometimes take place and sometimes not to take place. If we had events that would always take place, or if we had events that would never take place, they would be pretty useless. And the same goes for conditions. We require that conditions are sometimes met and sometimes they are not met. If we had conditions that would be always met or would never be met, it would not make too much sense to include them in our model. So this means that we now should really have a good impression of what we mean when we talk about the condition event nets.